Welcome back. In this video, we are going to discuss about caching. So caching is a very important optimization technique in Spark, which helps you save data frames in memory or on the disk or on both. Now, this is basically to help you avoid doing the calculations again and again. And the idea is to be able to reuse this data frame for subsequent operations downstream. So let's have a look at a few code snippets to better understand when can caching be used, right? So let's get started. So here I'm basically importing a few modules and I'm setting the Spark session over here. And I'm going to use the same customer data set that I've used for a few other of my experiments. And the data set is going to look something like this. It contains the customer ID and then a few other details about the customer. And let's have a look how all of this looks on the Spark UI. So the first job is for a Parquet file. Now, as we know that reading a file is not an action, right? So it shouldn't trigger a job, but you see a job being triggered over here, right? So this essentially means that the job is being triggered to be able to read metadata about what are the columns, what are the names of the column, what are the schema, and all of that, right? So for that reason, you also see that the input data size is 0 over here, right? And that is why it is just reading the metadata. The second one, which is a show string, you see that the input is 157.2 kilobytes, right? So here basically it reads in the customer's data frame and we have a base data frame over here, right? So we are going to compute a base data frame and we are going to use this base data frame multiple times for several operations, actually for just two operations over here, right? And the idea is to see whether base gets recalculated again and again, right? So let's go ahead and do that. And the way we build base is simply by doing two operations. The first one is a filter. We simply filter where city equals Boston, and we create a column called customer group wherein we essentially divide the customers between young, mid, old, and a kid, right? Depending on their age. And then we finally select the relevant columns, right? So let's go ahead and do a show on the base. So when we do a show, we would assume that this base data frame has been created, and that is why it was able to do a show, right? That is why it printed this data frame. Now we are going to create two more data frame, right? And these two more data frame builds on the base data frame. So we take the first data frame, add two columns. The first one is a text column and the second one is another column in which we add the birth year. So we simply split the birthday column and then get the second item, which is the year. So let's go ahead and see how the plan looks like. So this is the plan and we are going to come to this in more details. Let's also run the second one. In the second one we create the birth month and we do that again by simply splitting the birthday column and getting the first item. By first item I mean the item at the first index, right, which is this one, right? And then it adds the new column over here. So let's have a look at the two plans. So this is going to be the plan for the first one and this is going to be the plan for the second one. And let me just write without caching over here. So what we see over here is it reads your file and then it does a columnar to row and then finally it does a filter because we did a filter over here in the first data frame, right? So you see that in the query plan it is doing a filter, right? And the filter was supposed to be done on the base data frame, right? It was assumed that base data frame has already been created, but you see that the filter is being done, and then we added in two operations, which is creating two more columns. So those two columns are being created over here. The birth year is being created, and then the test column is being created, right? Now, what we also see is that a customer group is also being created over here. Now, we saw that customer group, creation of customer group was a part of the DF base data frame. It's not a part of DF1, right? Because in DF1 we just add into these two columns, right? Similarly for DF2, the data frame is red, columnar to row is done, and then a filter is done on the city, and then you again see that the birth month is created, which is good. The test column 2 is added, which is also good, but then what is not good is it it creates the customer group column again, right? It creates it again from scratch, right? So you see that the operation that it does for creating df1 and df2, it does it from the start to the end. It repeats all of the operation. It creates df base again. Now let's take a moment and try to understand why does it repeat the operation, right? And that is a little bit of why and how Spark works, right? So there is something called lazy evaluation in Spark, and what it does is that it waits until the last moment until an action is called, right? So what it does is that it starts from scratch, let's say reading in a file and then applying some transformations, and then it waits until an action is called. It doesn't do anything, right? And when the action is called, it is going to compute everything, right? So in our example, we are creating two data frames, right? df1 and we are creating df2, right? Now the way it is being created is that it is being built from df base, and from df base we are adding a test column 1, and we are also again adding a birth year, and then finally we are doing a dot show, which is an action. So this is going to trigger a job. Now a similar thing is happening for df2 as well. It is being created on top of df base, and we add in two more columns, which is called test column 2, and then another column called birth month, and then we do a dot show, right? So when we do a dot show, what it does is that it computes this lineage graph, this whole DAG again, right? So what it does is that it has already generated this DAG, right? DAG is a directed acyclic graph. So it has generated this DAG, and it is going to start executing from here. Now the moment it starts executing from here, it is going to first generate df base, and the way df base is generated is simply by doing this part over here, right? So it generates df base, and the moment df base is generated, it then adds these two columns, right? And similarly it would do the same for this one as well. It would go ahead and generate df base and then add in two columns, right? So that is why you see that all of these calculations are being repeated again, is being repeated twice. Now if you were to solve this, if you were to optimize this, what you would simply do, and you've got it right, you would simply cache this, just cache this, right? So what you do is that in your memory you just store df base, you just cache df base. So whenever df1 is being generated, df1 is going to look at, hey, I already have df base in my cache. So what I'm going to do, I'm going to take this and then I'm going to build on top of this. I'm going to add this and then I'm also going to add this, and that gives me my final answer, right? So that is how caching is going to help you, right? So now let's go ahead and have a look at how the code looks like. So we would see the Spark UI. The Spark UI would basically show us three jobs. This one I believe is for the second df1, and this one is for df2, and let's have a look at how they look like. We can just have a look at one of them. So you would see that it is scanning a Parquet file, right? And this Parquet file basically is df base, right? So it scans this Parquet file, and then it does a filter which was again on df1, sorry, on df base, and then finally it does all of the stuff that we did for df1, right? So it is creating a birth month, and it is also creating a test column too, right? So this basically shows that df base is being read in again. Now let me go ahead and make one simple change. Now what I'm going to do is I'm simply going to cache this data frame, and let's go ahead and run this again. We are going to look at the query plan, how the query plan looks like, but before that let's look at the job. Let me open a new tab. So let's look at the job. I believe these two are the jobs. And if we look at the DAG, here is something that you see really interesting, right? If you look at the scan parquet, it is 0. That means the parquet is not being scanned, right? This is 0, this whole stuff is 0. And instead of that, all of this is being replaced by an in-memory table scan. So inside of your memory, you have simply cached that data frame, df based data frame. So it simply goes ahead and reads it and applies all of the stuff that you need on top of this. It creates the birth month, and it also creates test column too, right? And it would do a similar thing for the other data frame as well. Um, yeah. So for the other one, all of this is 0 again. There is an in-memory table scan, and you would see birth year and test column 1 being created, right? So this is the beauty of caching. If you are using a data frame a lot of times in your operations, is optimal to cache that data frame, because it would end up computing the lineage graph again and again, and it would run that lineage graph, which would lead to consumption of more of your resources, right? Doing the same stuff again and again. So that is how caching could help you. And let's look at the query plan again. That would be interesting. Let's look at one of them. So here in the query plan, what we see is that this is an in-memory table scan, and this is what is important. So it basically reads in df base, and you see that the customer group column is already created. This basically is the summary of how the cache data frame is created. So this is not very important to read, but basically what it means is that here is a table, and that table looks something like this, and this table has been cached, and this step basically means that that cache table is being scanned, right? So what you finally see over here is in the query plan, the birth month is created over here, the test column 2 is created over here. Now you don't see the case when, right? You just see the customer group. So the customer group is simply referred from the one over here. It is not re-evaluated, recreated again, right? I believe that is how caching can help you. So I hope you're able to appreciate how caching can help you, right? Now let's understand what are the different types of caching, what are the different types of options that Spark provides you in order to cache your data frame, right? So these are a few options that I've listed down. These are the options that you could use in order to cache your data frame. So let's have a look at a few of them, right? So the default one basically is memory and disk desir. What this means is Spark is going to simply store your data frame both on memory and on disk in a deserialized format, right? Deserialized format basically means that your data is not stored in bytes, it is stored as JVM objects, so it is more easier to be able to read them, right? So that's the default, and the way to be able to read it is over here. So it is stored in disk and in memory, and it is deserialized, and this is replicated one, right? We will come to replication once again. So that is the basic and the default way of caching. Now let's have a look at the other ones, right? So for that I do an unpersist, because it has to first uncache this data frame in order to be able to cache it in another storage level. So now let's try to do it only on memory, right? Memory only, and then run df2. Now let's have a look. So now you see it's been changed to memory only, and the size in memory is 19.6 kilobytes, right? And it's been replicated only once. Now if we were to replicate, if we were to change this with memory only 2, this simply means that for resilience, store it 2 times, replicate it 2 times, right? And this is how it would look like. So it shows you 2x replicated, right? Now let's have a look at a few other ones, which is disk only. So disk only basically says stored in disk and is stored in a serialized format, right? And it's replicated one, and you would see that the size in memory becomes 0 while the size on disk becomes 19.6, right? And again, if you were to change it to disk only 2 or disk only 3, let's say we change it to disk only 3, this would basically show you that it's replicated 3x and it's serialized, right? So now let's look at another example, which would be memory and disk 2. Oops. So this basically shows you disk and memory. It is stored in a serialized format, and it is 2x replicated. So the size in memory is 19.6. Now you may wonder that if it is stored in disk and memory, why is the size on disk 0? This is because the size on memory is good enough to store what you have, and that is why it doesn't need to put the data on the disk, right? So those are a few examples on the different storage levels that you could use while caching. Now a very important thing to note is cache and persist are the same, right? The only difference is in cache you cannot provide a storage level. You cannot provide a storage level like this, right? In persist you can provide a storage level. So cache is basically equivalent to calling df.persist and the storage level being the default one, which is this one, right? But they are more or less the same, right? Now this is a basic chart. This is a chart that I found on the internet, and I think this is very useful because this tells you when is the space used either high or low, comparing it to various storage levels, right? So for example, for memory only, the space used is high because your data is present in a deserialized format as JVM objects, right? So the space used is high. The CPU time, the CPU cycle that it needs to process that is low because your data is already present in a deserialized format. It doesn't need to do any hard work in order to convert from serialized to deserialized, right? Now it's in the memory, it's not on disk, and it's not serialized. It's deserialized in the form of JVM objects, right? Memory only serialized basically refers to your data being present in the memory, but it is serialized, right? It is basically done basically to compact your data. So this shows that your space use is low, but the CPU time is going to be high because there's going to be some CPU cycles required in order to convert that data from serialized to deserialized format to be able to read it, right? And again, this is on memory, it's not on disk, and it's serialized, right? So similarly, you can have a look at this chart in order to understand when to use which kind of storage level. So I hope this video was able to give you a comprehensive overview on what caching is. It's great to see that you've completed the full video. If you found value, please don't forget to like, share, and subscribe to my YouTube channel. Thank you again for watching.